Hey there, how's it going today? We're looking at 3.6 on solving quadratic equations with the quadratic formula and also looking at the discriminant. And so our objectives for today are that you'll be able to solve quadratic equations by using the quadratic formula and using the determinant to determine the number and types of roots of a quadratic equation. This again applies to our standards where we're solving one variable problems including quadratics, and also to solve quadratics that have complex solutions. And so we're going to look at the quadratic formula. And so this is nothing new. This you should have seen 2 years ago in Algebra 1. But the solutions of a quadratic equation in standard form, and remember standard form of a quadratic equation, ax squared plus bx plus c equals 0, are given by the formula that x is equal to the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. Now there's some different songs that you can use, like Farajaka, and there's different ones out there that you could use. So give you an example: x equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. And so easy ways to remember the formula. Obviously you can't be singing it out loud during a test or something, but if you're humming in your head, you might remember it. Okay, and so we're going to use this, and so remember the a is in front of the x squared term, the b is in front of the x, the c is the constant, and we have to be set equal to 0 for this to work because we're looking for the solutions. Okay, and so as we look at example 1 here, and we kind of got them grouped by the types of solutions that we're going to see. So this is two rational roots here. 2x squared minus 16x is equal to 66. Well, we have to get it set equal to 0 first, and so I'm going to subtract the 66 from both sides. And so 2x squared minus 16x minus 66 is equal to 0. Now, you're probably saying to yourself, well, they're all even, so could I do something with that? Yeah, you actually can. So if everything will reduce, I could divide everything by a common factor, right? And so this will reduce. And so I get x squared minus 8x minus 33 is equal to 0. And we'll see that it doesn't matter if I use this or this, solutions will come out the same. The only thing is that this is a dilation factor, right? This would have been dilated by a factor of 2. This is not. But it doesn't affect the solutions. The solutions actually come out the same. It's where the vertex would be and how high or how low the graph is going and how quickly it gets there. That is the difference. And so I'm going to show it with both here just so you see that it does come out to the same solution. And so x equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. And so we're going to plug in our a, b, and c. So I'm going to start with this. So x is equal to the opposite of negative 16. And you'll notice that I'm not changing any signs yet, not doing any work. I'm just substituting when I first do this line. And so we get negative 16 squared minus 4 times 2 times negative 66. And that is going to be all over 2 times 2. And so now we're going to simplify what we've got. And so x is equal to, double negative is positive, so that's positive 16, plus or minus the square root. 16 squared is 256, minus, well, 2 negatives are going to give me a positive, and 8 times 66 is 528. And that's all over 4. And so x is equal to 16 plus or minus the square root. 256 plus 528 is 784. And that's all divided by 4. Now, if you know your perfect square is this high, you're going to recognize that 784 is a perfect square. And that perfect square is 28. All divided by 4. And so, as we talked about previously, when we have this plus or minus, I'm going to get two separate solutions. And so 16 plus 28 is 44 over the 4. Or I'm going to get the 16 minus the 20, and that's going to give me negative 12 over 4. And so my two solutions are 11 or negative 3. And so we see here, again, we've plugged in our ABCs all the way through and simplified down using ordered operations to get to my two separate solutions. Now, I said that we would do this a second time with that reduced one to show that it would work, right? And so my A is 1, my B is negative 8, and my C is negative 33. And so x is equal to the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. And so x is equal to the opposite of negative 8 plus or minus the square root of negative 8 squared minus 4 times 1 times negative 33 all over 2 times 1. So x is equal to 8 plus or minus the square root of 64. 4 times 33 is 132. And so we're going to get plus 132 all over 2. And so x is equal to 8 plus or minus the square root of 196 all divided by 2. Now this square root's a little bit easier, right? Because the square root of 196 is 14. Maybe you know that one a little bit better than 784 being 28. But look at that. 28, 14, something going on here. 8 plus 14 is going to give us 22 over the 2. Or we're going to get 8 minus the 14, and so that's going to give us negative 6 divided by the 2, and 22 divided by 2 is 11, and negative 6 divided by 2 is negative 3, and what do you know? It's the same two solutions we found over there. And so it doesn't matter if we reduce it first or not, we will get the same solutions if we do the work correctly. Now, is that work easier by reducing first? Absolutely. I mean, we had to multiply 8 times 66 and get 528. You know, you got to use a calculator. 4 times 33 is not so bad in your head sometimes. So again, this depends on the numbers that you have and what you can do with them. Okay? And so try this one out. You got x squared plus 13x minus 30 is equal to 0. Pause the video, try this quadratic, and solve it out. And so as we look at x squared plus 13x minus 30, so x equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. You'll see that I always write out these formulas because we want to plug and substitute everything in appropriately, and this causes less issues as you're looking through the formula. Again, the visual people will appreciate this more than some others. And so negative of 13, the opposite of 13 there, plus or minus 13 squared. And again, this is important why you need parentheses around everything you substitute when you first do it, because signs matter, over 2 times 1. And so the opposite of 13 is negative 13, plus or minus. 169 is 13 squared. And we're going to get negative times negative is a positive, and 4 and 30 is 120, all over 2. And so we're going to get that x is equal to negative 13 plus or minus the square root of 289 all over 2. And you're probably thinking in your head, well, what's the square root of 289? Well, that's 17 all over 2. Or negative 13 minus 17 is going to be negative 30 over 2. And reducing these, this is 2, and this is negative 15. So our two solutions are negative 15 and positive 2. All right, so there we go. So with one rational root, so what we're going to get here is one that'll still solve out, still going to do the same thing. X is equal to the opposite of b plus or minus the square root of b squared minus 4ac all over the 2a. So x is equal to the opposite of negative 34 plus or minus the square root of b squared. So that's negative 34 squared minus 4 times 1 times 289. Again, you might want to get your calculator handy for this one because it is going to be some large numbers that we're going to get. So the opposite of 34 is 34, plus or minus the square root of 34 squared, which is 1,156. We got minus 4 times 289, and that's going to be 1,156 all over 2. And so when we subtract this, well, this we don't need a calculator for. That's the same number, 0. So over the 2. Square root of 0 is 0, so 34 plus or minus 0 over the 2. And so when we do our two solutions, we're going to get 34 over 2 or 34 over 2 because adding 0 and subtracting 0 do the same thing. And so our only solution, which is a repeated solution, is 17. And so that's why there's only one rational root, because when this square root part comes out to 0, we get a repeated root. And let's move on to irrational roots. And so, same thing here. X equals the opposite of b, plus or minus the square root of b squared minus 4ac all over 2a. X is equal to the opposite of negative 6, plus or minus the square root of negative 6 squared minus 4 times 1 times 2 all over 2 times 1. X equals 6 plus or minus the square root of 36 minus 8 all over 2. And so 36 minus 8 is 28. So 6 plus or minus the square root of 28 all over 2. If this will simplify, we'll simplify it. And so the square root of 28 will break up to 4 and 7. And so x is equal to 6 plus or minus the square root of 4 times the square root of 7 all over 2. And so that's going to give us 6 plus or minus 2 root 7 all over 2. And all of our numbers that are outside are divisible by 2, so we will divide this and get 3 plus or minus the square root of 7. This is the solution. Well, two solutions actually, because it would be 3 plus the square root of 7, and then 3 minus the square root of 7. Square root of 7 is about 2.6, and so we're going to end up with something that's about 5.6, and then subtracting, getting about 0.4. And so if we need the decimals, we can go get those decimals, go into our calculator, and finding them to as many decimal places as we need. But if we don't need them, then this is the precise solution, and we need nothing else. Okay? So complex roots. So remember we talked about imaginary numbers back in section 3 with complex numbers. And so solving this one out, remember you need it solved for 0 first. So minus the 6x plus the 13 is equal to 0. And so now we'll go to our quadratic formula. All over 2a. And so the opposite of negative 6 plus or minus the square root of negative 6 squared minus 4 times 1 times 13 all over 2 times 1. And remember, these problems we're doing are simple numbers. Again, it doesn't matter if I've got simple numbers or complicated numbers. It will work out the same every time. And so equals 6 plus or minus the square root of 36. And this is 4 times 13 is 52, so minus 52 all over 2. And so from here, x is equal to 6 plus or minus the square root of negative 16 over 2. And square root of negative 16, well, that's going to involve an I. So 6 plus or minus I, but the square root of 16 is 4, so 4i all over 2. And again, if everything outside will divide, then we will be able to divide it. And so we're going to get 3 plus or minus 2i. That's our solution there. Again, that is two separate solutions. 3 plus the 2i, 3 minus the 2i are their two separate solutions to this. But that's it. We can't simplify this any further. We can't get it to a number because it's an imaginary number, and really this is complex, right? Because you have the real plus the imaginary portion. Okay? And so that is how we use the quadratic formula. And it doesn't matter what type of solution I'm going to get. It's the same process every time. Plug it into the formula and simplify it out to what you get. Okay? And so as we saw through these examples, we saw that the part under the radical, which we call the discriminant, is the piece that is going to tell us how many roots we have. And so if we go back and look at some of the examples, all right, well, this discriminant came out to a positive 289. This discriminant came out, not that example, coming back up here, this example came out to a square root of 784. But then we got to this one with a square root of 0. Well, these had two solutions, but this one had only one repeated solution. And so, and even when we get to a negative discriminant, we end up with an imaginary, right? And so that's our three cases. The b squared minus 4ac, that's the part under the radical. If the b squared minus 4ac, the discriminant, ends up positive, we end up with two real roots. Okay, so again, if we come out positive for our discriminant, we will have two real roots. They might be rational if that square root simplifies nicely, or they'll be irrational if the square root does not simplify nicely. If it is equal to 0, we will get one real repeated root. And I'm stressing this repeated part because when we get to later chapters, we're going to talk about the fundamental theorem of algebra, and that is going to cause us to talk about the number of roots that we have. And then when it's less than 0, we're going to get 2 complex roots when we're less than 0, so when our discriminant is negative. And so using this real quick, we're going to talk about what type of roots might come out of an example. And so it says find the value of the discriminant and then describe the number of type of roots. So we're not looking for what is the solution or what are the roots. We're just asking what are the type of roots based on the value of the discriminant. So remember, the discriminant is b squared minus 4ac. So I'm going to get 3 squared minus 4 times 1 times 5. And so that's 9 minus 20, which is negative 11. Well, my discriminant came out negative, so that means I have 2 complex roots. Not telling me what those roots are, but again, we could solve from here. And using the discriminant is really nice because we can take this and now plug into our quadratic formula if we need to. Because remember, the discriminant is fit nicely under that radical there. And so when we plug this in, x equals the opposite of 3 plus or minus, we've already simplified this entire radical part down. And so 2 over 1, and we could work the rest of the way down to find our solutions if we need to. But again, this example just asked us to find what is the discriminant and what type of solutions would it have. And so I'll give you one more to try here real quick. So x squared minus 11x plus 10 is equal to 0. Figure out what is the discriminant and what type of solutions it's going to have. And so pause the video here real quick and then we'll look at it. All right, so if you tried it out, let's see what you got. We're going to get that b squared minus 4ac, and so I'm going to get the negative 11 squared minus 4 times 1 times 10. So I've got 121 minus 40, which is 81. So my discriminant is going to show me that I have 2 real roots. Now, 81 is a perfect square, so when I take the square root, it's going to come out to 9. So I'm actually going to get 2 rational roots in the end of this. And again, we could go into the quadratic formula and find out those solutions. But again, this question was just what is the value of the discriminant and the number and types of roots. So that's where we stop there. Okay, and so the last thing we're going to look at is just kind of reviewing this entire chapter so far. Our 5 different methods that we've talked about. So we talked about graphing back in sections 1 and 2. Talked about factoring in section 4. Talked about the square root property in section 5, along with completing the square. And then the quadratic formula in section 6. So again, 2, 4, 5, 5, and 6. Those are the section numbers that you can go back to reference those. And so when are they useful? Well, graphing, factoring, square roots are only sometimes useful because they are good for certain cases, but not for others. So like graphing is great if we want to check the solution, or if the solutions are integer values and we see it cross nicely on the graph. Again, if you have a graphing calculator, it'll calculate it, but again, careful with the TI 83s and 84s. Sometimes there's some rounding issues that go on in those calculators that give you an issue. Factoring, so again, it's nice when it's equal to 0 already, and the factors are easily found using, remember, our X puzzle, right? So A times C on the top, B on the bottom. Square root's nice when it's already set, like X minus 4 squared is equal to 16. We can solve that pretty easily. But again, those are only good when it's set up kind of nicely. Completing the square will always work. But it's best when the a is equal to 1 and the b is even. Again, we could do it when the a is not 1. We could do it when the b is odd, or the b is some other value. But it's best used when the a is 1 already and the b is even. And remember, we want our equation set equal to 0 for that. And finally, the quadratic formula is always useful because it will always work when all else fails or the numbers are too complicated for another method. Again, be paying attention to that. And so your word of the day is the quadratic formula, or phrase of the day for some of you who are technical. And so hope you all have a great day and catch you on the flip side.